say this much. Okay, so another thing that followed from considering this matrix that we want to reduce, we're going to get at least n minus m rows that have all zeros with something else. Maybe a zero, maybe not. Okay? But we'll get at least that many rows. Okay? So we're going to get at most m rows that aren't of this form. Now, if they aren't of this form and we've completely reduced it, then they're of this form, zeros up through a leading one, and then maybe with some zeros and maybe non-zeros following. But as soon as we have a 1 here, then we know if this 1 is like in the 4th position, we know that C4 isn't going to be 0. Okay? They're going to be 3 variables or something. Okay? You think about what we would have, but we know that we have a solution for that, and for every variable that appears with a 1 here, right? And then for some free variables. Okay. Now, I'm not going to be completely rigorous here, because if I say too much, it's just not, we'll fill some details in Tuesday. Okay, but the bottom line here is then if there exist m such rows, then your set V1 through Vm, and remember m is the number of vectors you have. Okay, you could think, for example, 3 vectors in R5. Okay, R5 is 5-dimensional. It requires 5 vectors to span it. 5 linearly independent vectors will span it. But if we've only got 3 of them, it won't span all of R5. That's what all this shows. Okay? But if there are m rows of this form, it follows that this is a linear independent set. Okay? In this case, span of this set is a subspace of Rn. Okay? Now that n I wrote over it. Understand that's an n, okay? Because that's the space we're talking about. The set is linearly independent. Okay? So the span of V1 through Vm is a subspace with basis V1 through Vm. Why? Because V1 through Vm is linearly independent. Okay? And it, of course, spans the space that it spans. Okay? And that is a subspace. Span of any set of vectors in a vector space is a subspace. Easily proven. And I kind of count on me to ask you to prove that. Okay? Make sense? Not totally, because I'm leaving some stuff out here. I'm not proving everything with absolute rigor. You're not ready to hear that. Okay? Giving you kind of a conceptual idea. Okay, well, so that's what we have. Now,
even if you work in the prep store, you have to do this.
if there are less than m rows of this general form, okay? then this can't be linearly independent. Okay? Now, I'm not proving this, I'm just asserting it. Some subset, however, is linearly independent. Okay? And is a basis for the span of V1 through Vm. Okay? Now, kind of a big deal statement. Several. It's not a totally rigorous statement. I haven't stated all the conditions, but the feel is this. No matter what set, because there could be other sets that span this space, right? No matter what other set spans this subspace or this space Rn, it's always going to have the same number of vectors. Okay? Any linearly independent set that spans a given vector space, whether it's a subspace or a whole space or whatever, has to have the same number of vectors as any other linearly independent spanning space. Okay? This number is what we call the dimension of the space or subspace. Okay? Halfway make sense? Okay. This means, for example, in R2, we just saw, well, it's not up there anymore, but we just saw a basis for R2, a linearly independent spanning set. We proved it. Okay? We're generalizing to bigger spaces now, but all the same ideas apply. Okay? In R2, in order to span R2, you need at least 2 vectors. Now, you could have 12 vectors that span R2, or you could find a subset of those 12 containing only 2 vectors that spans R2. And say the same thing about R3, okay? So you can always find, if you've got any number of vectors that span R2, you can always reduce that set down to 2 vectors that span it. Now, it might be that you have 1 vector and then another vector and then 12 more vectors that are all multiples of the second one. Okay? Well, any one of those 12 with the first one would span. I want to think about that visually a little bit. Okay? Now that I'm out of board space, I got to say the really important stuff, so I got to fix that. So ponder this for a minute, kind of digest it a little bit, and we'll clean a board. I had plenty. I just must be overly verbose today or something.